So, good morning, all. Welcome to lecture 16 on the course Data Structure and Algorithm. In the previous class, we wrapped up our understanding and discussion on single linked list and double linked list, and we understood complexity analysis of few algorithms of the operations on single and double linked list. In today's lecture, we will introduce a new topic in this course, another scheme of data structure which is known as stack. So I hope my screen is visible to all of you. So as per the course planner, uh, array operations which are covered so far, linear search and binary search and their performance comparison is also done. Uh, Single linked list, double linked list are covered. So I am leaving circle linked list for the time being. Okay, so we shall actually conduct a tutorial class where circular linked list will be covered. Okay, and then and you know an open assignment is available, polynomial addition and multiplication. ঠিক আছে? So I shall provide you the detailed problem statement regarding this open assignment. Okay, so this is the module 2 which we are starting today. Okay. Stack principle, stack operations. This one. So stack is a scheme of data structure. I mean, stack is scheme of data structure where the elements are organized, means stored in such a way, in such a way that element in such a way or in such an or an order. So what is the order of storage? So that is important in this case. Okay, so far in the data structure like linked list or in array you have seen. So the operations are like insertion, deletion. So while we are doing insertion, we are concerned about the position where we are inserting the new element in the array or in the linked list. ঠিক আছে? But here what we are doing, we are not in a position to insert a new node at any random position. That is not allowed. No option like that is available to us. Okay, so in array linked list, you can insert a new node at any position as per the uh, mm, desire of the user. ঠিক আছে? but there is no such provision. You can't add any new node or new element in any random position. That is not possible. Okay, so the elements are organized in such a way or an order that element stored last can be deleted first. Okay, so here new element cannot be stored at any random position, unlike array or or linked list operations. Okay, so basically position of insertion is not in our hand. It's fixed. Okay, it's fixed. ঠিক আছে, বুঝা গেল যে এখানে
Yes,
কোন
sir.
পজিশনে তুমি ইনসার্ট করবে সেটা কিন্তু তোমার হাতে নেই। ঠিক আছে, তুমি you are forcefully you are forcefully bound to insert a new element or delete an existing element from that fixed position. Fixed position means defined position. It's already defined. You can't alter the position. You can't insert an element in any position as per your choice, or you can't delete an element, existing element from any position from where you want to delete. Okay, so position is fixed. Okay, so only instance in our hand is what to insert or what to delete. It's not in our hand that where to insert or delete. Okay. The main scheme is this one. The elements in that way, in that case, the elements are stored in some order, and the order is maintained in such a way that the element which is getting inserted last, latest, that can be deleted first only. Okay, so here major operations are number one, pop, and two, sorry, first I have written pop, push, and pop. Okay, push means it is like insertion of a new node. Okay, so adding a new element, it may be some array element or maybe some linked list node. That's it. So we will do the both stack using array, stack using linked list. Both are possible. Okay. So whatever element you are adding, that's up to you. If you are adding a simple integer element, you can you can go for stack using array, or if you are actually trying to build a linked list which is maintaining the scheme of the stack, then it's also possible. So adding a new node, new element in the stack data structure. It's a scheme, some policy it is having. We earlierly had understood that. So we will be studying different schemes of data structure. So linked list is having its own data structure scheme. Okay, single linked list. Double linked list is having its own policy. Stack is also having its own policy. What is the policy? These are the policy. This is the policy. Okay, so adding a new node in the stack data structure. Okay, Then pop is deleting or removing element from the stack data structure. Where you are adding or removing, that is not in our concern because it is fixed. It is not in our hand. Now let's get some picture to understand, to visualize what is actually stack. Uh, okay, so I'm drawing in a vertical manner. Generally, people understand stack like this kind of vertical memory stack. Okay, you may also target like this, or you may also. It's not a problem, horizontal or vertical, whatever. The main concept is same. Okay, and dot. Okay, so this is looking like an array. This is also looking like a horizontal array, vertical array, something like that. So yes, these are contiguous memory locations. These are contiguous memory locations. If the address of this memory location is, let's say, 1000, and if the content of this address, let's say, uh, mm, requires, let's say, 2 bytes of memory, then address of this is 1000. So address of this is 1002. Address of this location is 1004. So these memory addresses are contiguous in nature. Okay. Now, interesting part is, so let's say we want to, okay, so I told you there should be an order of storage of the elements, sequential order of storage of elements. Suppose I want to store few data, let's say integer data. So, for example, first I want to store 5, okay, then I want to store, let's say, 7. So, we are, uh, considering some kind of an order of storage. When when to store, not where to store. Okay, 5 first is being stored, then 7 is stored, then let's say 2 is stored, and then 10 is supposed to be stored, like that. 4 elements, for example. So what will happen? So this is, let's say, here I'm storing 5. Okay, then I'm storing 7, then I'm storing 2, and then we are storing 10. Okay, so you can see it is like a stack of books. You are placing a book on the table, and above it you are placing another book, and then above it you are placing another book, and like that. So we call this as a stack of books. This is similar kind of an organization. So now if you want to place another book, okay, where can you place that book? At the top of the stack, always. You can't actually insert a book anywhere in the middle. Okay, so that is the skill. Now see if, let's say, after 10 I want to add another element to the into the stack. The question is, where can I store that data? 8. We are bound to store that data at this position only, at the top of the stack, here, like this. In this manner the stack organization is going on. Okay, so adding this kind of element at the top of the stack only, where we are storing the data at the top of the stack. ঠিক আছে? So the top of the stack is the only given position of addition of a new node. Okay, fine. Yes, bolo. Okay, okay. So we call this as a top of the stack. Top of stack. Okay. That means you require a pointer or someone who is supposed to track this position, which is the top of the stack at any situation, right? Okay, so we understand from this situation that we require a a pointer which is point towards. So top is a pointer, always point to the top position of this stack. Okay, right. And below it, what is there? Null, nothing. Okay, so if you like, okay. Next, and also we want to assume for practical implementation, we want to assume that the size of the stack is limited, fixed. So if you want to implement stack using array, the array size should be kept fixed. It should not be enlarged or compressed. ঠিক আছে? So that means it is having some capacity. So capacity to store some limited number of elements. So if sometimes it happens that the number of elements to be added exceeds the capacity, then that situation we call as stack overflow. Okay, stack overflow means when number of uh, elements to be added becomes more than the capacity or the size of the stack. This situation we call as stack overflow, and we want to also implement this feature, stack overflow. Okay? And similarly, we may have another situation, stack underflow, means when the number of elements to be added, okay, when the stack is empty, simply when stack is empty. Okay, fine. Now, uh, okay, now in this situation, let me show you what is actually pop operation. Pop operation means, you know, whenever you want to do a pop, you are or not in a position what to pop. No, you are not in a position to ask the user what to pop and from where to pop. Pop means delete or removal of an element, existing element. So from where you want to remove an element, that is not up to you, and what you want to remove, that is also not in your hand. So simply, if you want to, if you wish to pop out an element from the stack, that means it has to be popped out, okay, from the top position, from this position, okay, and what to be popped out, this 8 element only. So if you just wish to pop out an element, this 8 will be simply popped out because it is added last into the stack. So once it is popped out, then at the top, at the top of the stack, the last element which is available is 10. So then if you want to pop out another element, then this 10 will be popped out. Okay, so push function requires the value of the data to be added into the stack, but pop does not require any argument. These are the function prototype. Okay, push, val, pop, nothing. Right. ঠিক আছে? Okay. Now let's come in more detail. uh, let's say logical development using array, for example. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the stack is having a capacity 9. Okay, so now as it is an array, so its index is starting with 0 and ending with at. So you introduce one variable which is top, which is supposed to track the top position of the stack. ठीक है? And we call this name of this array. Okay, let's say the name of this array is stack. So this location element can be accessed by stack 0, stack 1, stack 2, dot 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 up to this is stack 8. Okay, fine. Now underflow. Underflow means initially top should be equal to initialized to -1. Initially top should be initialized to -1. Okay, uh, point to top position of stack. This is the purpose. Okay, fine. So underflow means stack is empty. Suppose you are adding an element, let's say 2. So then what will happen? Let me take again. So if I want to add, and in this situation where the stack is empty, if I want to add an element, let's say 2. So what is the process? The first step is step 1. Top will be incremented to 1, incremented by 1, top plus plus, so that top is becoming equal to 0. From -1, if you add 1, it will become 0. So if top equal to 0, that means top is pointing towards this. We can say top equal to 0 means it is the index of this location of this stack array. Okay, so then what you do, you store the user given value into that position. How? By this stack, then give the index top, and then store the assign the user given value this much, stack top equal to val. So then user given value, let's say 2, will be assigned in this. So this is the process, two-step process. First, the top variable will be incremented by 1 to move top to the desired location where the new element will be inserted or added, and then assign the value over there. That's it. Okay, so if and whenever you are doing pop, so this is push. Okay, so this is a push operation, and in case of pop, what happens? You remove the element. Okay, uh, uh, let me check once. What is the assumption? Okay, so Okay, no issue. Here, just you do top minus minus. Just you do top minus minus. Means suppose, let's say 2, 4 are the elements. Okay, and top is pointing towards this. Okay, so it is pointing towards the top position. Okay, so whenever you want to insert a new element, so it will be incremented by 1 so that it is pointing towards here, and then you assign the user given value in this location. That is the procedure in case of push. Now in case of pop, what you are doing, you are simply decrementing the top value by 1 so that it is now pointing towards this location, decrementing by 1. Okay, so this connection is lost. So top is pointing towards this location. So it's like, okay, this is like at any random situation. Okay, any random situation, this is position equal to 0, position index 0, and this is the position index what? Top, because top is pointing towards this. So if this is the situation at any time, then if you want to display all the contents of the stack, so it should display the content of the stack for this part. Okay, this portion of the entire memory location. You will forget about what is there beyond this thing. So what is the available stack? Only this portion, single element. Okay, so in this picture there may be some other locations, next locations, where these next locations may store some value, some previously stored value, some garbage value, but it doesn't matter. But the starting position is 0 and the ending position should be top. Okay? So this is the region of the stack where some valuable information is stored. And if you want to display the stack, it should display this much content, 0 to top. Okay, so if you understand in this way, that means that means if you do simply top minus minus, you can say that okay, an element is being removed from the stack, because this is our stack at any situation, 0 to top. Here top, this is top. So 0 to top means up to this portion we have the stack. What is there beyond it, we are not bothered about it. That means 4 is logically being removed from the stack, right? So that is the thing. We are not doing any memory deallocation. But whenever we will do stack using linked list, then we shall do memory deallocation also. Then proper meaning of pop will be done. Okay. Okay, so I hope you have understood. Very easy logic, very easy algorithm. Okay, we have seen that there's 2-step push and 1-step pop. Okay, so now let's go for the algorithm underflow. Okay, sorry. So underflow means,
Sir,
yes.
sir, how we can display the stack?
Just display the content of this array, which is named as stack, starting from the position index 0, ending with the position index pop. That's all.
Okay, sir.
So underflow means if you further pop, okay, pop an element from the stack in this situation where top is pointing towards 2. So what will happen? Due to top minus minus, now at this situation top is equal to 0. But if you do top minus minus, it will point towards somewhere here, just before 2, means where the position index equal to -1. Okay, so top is no longer pointing towards this 2. That means 2 and 4 both are being logically removed from the stack. So this is the situation where stack becomes empty. logically stack becomes empty. Okay, so how to check whether stack becomes empty or not? That just check that whether top is equal to -1 or not. This is the underflow condition. And overflow condition similarly. And you know you have a capacity of the overall stack, that is in this case 9, means what can be the maximum value of top, that is 8,
Capacity -1.
right? Capacity -1. So you can say that, okay, if the size of the array uh, capacity, let's say give some variable, let's say n or small n equal to 9. So in that case n-1. So if top reaches equal to n-1, by that we have to understand stack is already full. So if you further, when a stack is already full, that is not the overflow condition. Stack is full, but whenever you are trying to attempt to add a new element when the stack is full, then that situation will become in underflow, a overflow condition. That is the thing. Okay. Similarly, when your stack is empty and you are trying to pop out an element, pop out means you are trying to just pop out one element, then the stack will go into an underflow situation. And nothing I have to pop out. How can I do a pop out? Okay. So this is the portion. Now next, coming to algorithm development, I think now it will be more clear. Okay. So initially we have to do top equal to -1. The algorithm development using array I'm doing, very easy. Okay, top equal to -1. This memory allocation is already there and its name is stack, right? So just top equal to -1, and then read val, oh sorry, then you call a function push, okay, array, that's it. And there you are, so you will do a switch case, right? Menu option, either push or pop. So I'm not writing here in the keyboard in that thing. Okay. Push function, push function here, push array val. Okay. Next, pop function call, that is pop array. That's it. So this is the main function, algorithm for the main function. Now, anywhere in the memory, there is the function definition of push. Okay. What is there? So what is the function definition, prototype template? Push array, and here val, right? Okay, so already read val is there, right? Here we are doing read val, right? So what you have to do, plus plus, okay. You have to check the overflow condition. If top is equal to n-1, then display stack overflow, and if else,
স্যার তখন কি স্ট্যাক ওভারফ্লো ডিসপ্লে করব আর স্ট্যাক ইজ ফুল এটা ডিসপ্লে করব স্যার n-1 তো স্যার যখন n-1 দিচ্ছি আমরা কন্ডিশন তখন কি স্ট্যাক ওভারফ্লো আমরা ডিসপ্লে করব না স্ট্যাক ইজ ফুল আমরা ডিসপ্লে করব chunk at
Stack
that point
overflow.
to full.
Stack Overflow.
Acha.
Because already addition of an element is being attempted. Okay.
Okay, okay,
So
okay, okay.
top plus plus. So top plus plus. So top plus plus করলে then stack top. এটা যদিও সিনট্যাক্স হয়ে গেল, ঠিক আছে, তাহলে ফার্স্ট ব্র্যাকেট দিচ্ছি অ্যাটলিস্ট, ঠিক আছে দরকার নেই। stack top is equal to val and else. That's it. Okay. So next, it is very easy algorithm. You can see using algorithm. কিছু নেই, function definition of pop, that is pop array কটা আছে তিনশো। Okay. Again you are checking if top is equal to -1, then display stack on the flow, and if else top minus minus, or top equal to top -1 and else that's it. Very easy. So let's go for the program implementation. I think very small code you have to do. First, creating a menu option. Okay. So here I am reading the val. Okay. Just blindly doing this. Okay, right. This is the এরপরে কার ক্লাস আছে?
মনে হয় দাদা মুস্তফা স্যার
হয়ে এসছে অলমোস্ট। So if underflow uh, top should be initialized. Okay, globally declared because the other function, all the functions should access it. Globally declared variable. So if top equal to -1, stack overflow.
আচ্ছা স্যার, এটা তো স্যার n-1 হবে তো স্যার, -1
হ্যাঁ
তো
স্যার n
আন্ডারফ্লো
তো কন্ডিশনটা ভুল হয়ে গেছে।
n-1 হবে তো।
হ্যাঁ,
ইয়েস স্যার।
স্যার এখানে মনে হয় শুধু 9 হবে, কারণ এখানে n নিইনি, আমরা 10 নিয়েছি জাস্ট।
ওটা জেনারেলাইজ করতে হবে আর কি পরে।
হ্যাঁ।
তাড়াহুড়ো করতে গিয়ে আর করছি না। জাস্ট বেসিক জিনিসটা দেখিয়ে দিই।
হ্যাঁ
স্ট্যাকটাকেও অ্যাক্সেস করতে হবে, তাহলে এটাকেও গ্লোবালি ডিক্লেয়ার করতে হবে। ঠিক আছে, হয়ে গেল।
হ্যাঁ
নেক্সট হচ্ছে পপ ফাংশন। ওকে, এখানে দেখো এই আন্ডারফ্লো কন্ডিশন। ঠিক আছে, এলস দ্যাটস ইট। ওকে, তাহলে একটা ডিসপ্লে চাই। ডিসপ্লে চাই। less than equal to top. Stack top, right? Stack I. That's it. ওকে, তাহলে প্রত্যেকবার কপি করে নেওয়ার পরে ডিসপ্লে কল করে দেবো। তাহলে আর মেনু অপশন দিলাম না এই মুহূর্তে। ঠিক আছে, কত 31? আচ্ছা, ডিসপ্লে ডিসপ্লে প্রত্যেকটার প্রোটোটাইপ আমাকে নিতে হবে ইনিশিয়ালি। Hello? Okay. Oh, এটা টপ হবে। ঠিক আছে? নোয়েরা? Okay. So enter a value, let's say 10, রিটার্ন হয়ে যাচ্ছে না ডিসপ্লেতে? ওকে ওকে। তাহলে আম, তাহলে while loop ক্রিয়েট করতে হবে, একটুখানি হয়ে গেল, এখনই হয়ে গেল। while 1, okay, এক্সিট করার সময় কিন্তু ডিসপ্লে পরে এটা ইয়ে হয়ে যাবে, রিটার্ন হয়ে যাবে, ডিসপ্লের পরে রিটার্ন হয়ে যাবে। কোথায় ডিসপ্লে? আচ্ছা, তাহলে এখানেই দিতে হবে। এক্সিটটা না করে ডিসপ্লে। all true players. Okay, you can see 1040. If I do pop, okay, it's fine now. Hello?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
20. See, now popping. 30. Another pop. Another pop. So display 1020. ঠিক আছে? Okay, so thank you.
Sir, is there any other things to do except push and pop?
No, in stack, these are the major two operations.
Acha.
Yes. Okay, so this is for all today. Mustafa sir is waiting, and let me check to the attendance very quickly. Thank you for the. I hope the lecture is very easy for all of you.